Every time I look at this video from the James Webb Space Telescope, I'm reminded of something powerful. Even in the middle of what looks like pure chaos, there are hidden patterns. Patterns that shape galaxies, patterns that give birth to stars, and even patterns that shape our bodies. Because just like this sky full of stars, our nutrition and metabolism also look chaotic on the surface. But underneath, there is a structure and an image or a shape waiting to be revealed. Have you ever met someone who eats almost the same food as you, yet their body reacts in a completely different way? One person gains weight, another doesn't. One develops insulin resistance, the other stays perfectly healthy. For years, these differences looked like mysteries, until we discovered that our data carries hidden patterns that explain why our bodies behave so differently. Before I explain how PCA uncovers these patterns, I want to tell you the moment everything clicked for me. When I first started analyzing nutrition datasets, hundreds of variables from food intake, blood and fecal markers, metabolism, it felt exactly like staring at a sky full of stars, with no idea which constellation to follow. Then I came across a talk by Professor Rasmus Bro from the Chemometrics and Machine Learning group in Copenhagen. The way he explained PCA was so clear, elegant, and intuitive that suddenly the entire sky made sense. And I want you to hear a short part of that explanation from him.
Let's start with a simple example of how the brain works. If we want to recognize a face, we usually don't look at variables one at a time. Let's have a look at one variable or one feature below, the nose, and try and figure out who that person might be. That's not very simple in this case. But we could look at another feature or another variable instead. For example, the eye. Or we could look at both simultaneously. And even though it helps to look at both, it's not really simple to see which person it is. But if we look at the whole image, there's absolutely no problem. It's quite simple to see who it is. So, the brain does not look at individual features. It doesn't look at the levels of the individual features, but rather it looks at the relations, all the different relations between different features. And we would like to have something similar when we look at data in different problems.
When Rasmus describes PCA as finding the main directions in your data, that is exactly what we do in nutrition science. Think of your life as a giant table filled with dozens of ingredients: your meals, stress, sleep hours, blood sugar, cravings, activity, your microbiome, your emotions. It looks chaotic, it feels chaotic. But PCA organizes that chaos. It reduces dozens of variables into a few simple patterns. One pattern for high sugar, high energy eating, one for high quality fiber-rich diets, one for emotional or irregular eating. And suddenly, the picture becomes clear. We see which pattern pull you toward health and which ones pull you toward obesity, insulin resistance, or metabolic imbalance. Instead of drowning in 70 variables, PCA reveals the story hidden inside your data. Here's the most important part. Your health is not defined by one number, not your BMI, not your glucose, or not one bad day. Your health is a direction, a pattern. And the beautiful thing is, patterns can change. Once you recognize your own pattern, like stress eating, sugar dependence, low energy, or irregular routines, you can gently shift it toward a healthier one. PCA teaches us something profound. Behind every complex life, there is a structure, and once you see it, you can transform it. Thank you for listening. I'm Negar, a researcher in nutrition, food science, and machine learning-based data analysis, and this was your Science Podcast. Stay healthy, stay curious, and I'll see you in the next episode.